Welcome to our exploration of how mathematics and science come together to unlock the mysteries of the universe. Today, we'll focus on the pivotal role mathematics plays in scientific inquiry, especially through the groundbreaking work of Isaac Newton. By understanding this integration, we can appreciate how abstract numbers and logical reasoning help us describe, predict, and even control the world around us. Let's embark on this journey, starting with the basics of how math and science are intertwined. Scientific inquiry is the process by which scientists ask questions about the natural world and seek answers through observation, experimentation, and analysis. Mathematics is essential in this process, providing the language and tools needed to quantify results, identify patterns, and make predictions. Without math, scientific inquiry would be limited to qualitative descriptions, lacking the precision and rigor needed for true understanding. This foundational relationship sets the stage for all scientific advancements. Mathematics serves as the universal language of science. Whether it's measuring the speed of a falling object or calculating the orbit of a planet, math allows scientists to express complex ideas with clarity and accuracy. Equations, graphs, and models become the tools that bridge theory and reality, making it possible to test hypotheses and communicate findings across cultures and generations. Isaac Newton stands as one of history's most influential scientists, seamlessly blending mathematics with scientific exploration. His curiosity about the world led him to develop new mathematical tools such as calculus, which he used to solve problems that had puzzled thinkers for centuries. Newton's approach set a new standard for scientific investigation, showing that math and science are inseparable partners in discovery. Calculus, co-invented by Newton, revolutionized mathematics and science. It provided a way to analyze change and motion, which are central to understanding the physical world. With calculus, scientists could now describe how objects accelerate, how planets move, and how forces interact. This mathematical breakthrough became the foundation for modern physics and engineering. Newton's three laws of motion are perhaps his most famous contribution. These laws describe how objects move and interact, forming the backbone of classical mechanics. By expressing these laws mathematically, Newton enabled scientists to predict the behavior of everything from falling apples to orbiting planets. The precision of his equations marked a turning point in scientific history. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This simple yet profound idea explains why you need to push a stationary car to get it moving, or why a rolling ball eventually stops due to friction. The law of inertia is a cornerstone of physics, grounded in mathematical reasoning. Newton's second law introduces the relationship between force, mass, and acceleration, famously captured by the equation F equals ma. This law tells us that the acceleration of an object depends on its mass and the force applied to it. It's why heavier objects require more force to move, and why rockets need powerful engines to escape Earth's gravity. The mathematical clarity of this law allows engineers and scientists to design everything from bridges to spacecraft. Newton's third law states that for every action there is an equal and opposite reaction. This principle is visible in countless situations, from a swimmer pushing off the pool wall to a rocket launching into space. The law's mathematical expression helps us calculate the forces involved, ensuring safety and efficiency in engineering and technology. Mathematics is not just for theory, it's crucial in designing and interpreting experiments. Scientists use math to measure results, analyze data, and determine the reliability of their findings. Whether it's calculating averages, plotting graphs, or running statistical tests, math ensures that scientific conclusions are based on solid evidence. One of the most powerful outcomes of integrating mathematics with science is the ability to predict natural phenomena. From forecasting eclipses to modeling climate change, mathematical equations allow scientists to anticipate events before they happen. This predictive power is a testament to the deep connection between math and the natural world. Newton's laws are called universal because they apply everywhere, from the smallest pebble to the largest planet. The mathematical form of these laws means they can be tested and confirmed in any context, making them a cornerstone of scientific understanding. This universality is what makes Newton's work so enduring and influential. Newton's law of universal gravitation is another example of math illuminating science. By expressing gravity as a mathematical equation, Newton explained why apples fall and planets orbit the sun. This law unified the heavens and the earth under a single principle, showing the power of mathematical thinking. Newton's genius lay in his ability to observe natural phenomena and translate them into mathematical language. By carefully measuring and analyzing, he turned everyday experiences into universal laws. This process, moving from observation to equation, is at the heart of scientific discovery. Mathematics provides the rigorous proofs that underpin scientific theories. Newton's work was not just based on intuition or guesswork, he used logical reasoning and mathematical demonstration to support his ideas. This insistence on proof is what gives science its reliability and credibility. The integration of mathematics and science has fueled technological progress for centuries. From the steam engine to the smartphone, every major invention relies on mathematical principles. Newton's laws, in particular, are essential for engineering, construction, and countless modern technologies. Newton's integration of math and science continues to inspire students and researchers around the world. His work is a central part of science education, teaching us not only about the physical world but also about the power of logical thinking. By studying Newton, we learn how curiosity and rigor can lead to profound discoveries. Story of mathematics and science is also a story of collaboration. Newton built on the work of earlier mathematicians and scientists, and his discoveries paved the way for future breakthroughs. Today, interdisciplinary research continues this tradition, blending math, physics, engineering, and more to solve complex problems. At the heart of scientific inquiry is the scientific method, a systematic approach that relies heavily on mathematics. From forming hypotheses to analyzing results, each step is guided by logical reasoning and quantitative analysis. Newton's work exemplifies this method, showing how careful measurement and calculation lead to reliable knowledge. Isaac Newton's legacy endures not just in his laws but in the way he transformed science itself. By integrating mathematics into scientific inquiry, he set a new standard for how we explore and understand the universe. His influence can be seen in every branch of science, from astronomy to engineering. Newton's mathematical approach laid the groundwork for modern physics. Later scientists such as Einstein built on his ideas to develop new theories that describe the universe in even greater detail. The tradition of using mathematics to unlock nature's secrets continues to drive scientific progress today. The integration of mathematics and science isn't just for academics, it affects our daily lives. From predicting the weather to designing safer cars, the principles Newton established help make our world more understandable and manageable. Math and science together improve our quality of life in countless ways. Mathematics allows scientists to abstract complex phenomena, stripping away details to reveal underlying patterns. Newton's equations, for example, apply to everything from a rolling ball to a planet in orbit. This power of abstraction makes math an indispensable tool for scientific discovery. Graphs, diagrams, and models are vital for visualizing scientific ideas. Newton's work inspired new ways to represent motion and force, making abstract concepts more accessible. Today, visualization remains a key part of scientific communication and education. Scientific theories are constantly tested and refined using mathematical analysis. Newton's laws have been confirmed in countless experiments, but science always remains open to new evidence. This ongoing process ensures that our understanding of the universe becomes ever more accurate. Newton's integration of math and science influenced not just physics, but chemistry, biology, and even economics. The mathematical approach to inquiry has become a model for all scientific disciplines, demonstrating the universal value of quantitative reasoning. While mathematics is a powerful tool, it has its limitations. Not all scientific questions can be answered with equations alone. Newton's work reminds us that observation, creativity, and open-mindedness are also essential in the quest for knowledge. Today's scientists continue Newton's tradition, using mathematics to explore everything from the smallest particles to the largest galaxies. The integration of math and science remains at the heart of discovery, driving progress in fields as diverse as medicine, engineering, and environmental science. The integration of mathematics and science exemplified by Newton's work has changed the world. It has given us the tools to understand, predict, and shape our environment. As we look to the future, this powerful partnership will continue to inspire new generations of thinkers and innovators. Summary: the integration of mathematics and science, championed by Isaac Newton, has revolutionized our understanding of the universe. By combining logical reasoning with careful observation, we have unlocked secrets of motion, force, and gravity. This legacy reminds us that curiosity, rigor, and creativity are the keys to discovery. Thank you for joining us on this journey through the world of math and science.